Algebra 2, section 2.7, two variable inequalities. We're going to talk about linear inequalities and then absolute value inequalities. So linear meaning line, meaning something that would be like this is slope-intercept form, except that it's not equals, it's greater than, right? We've got that to deal with, okay? Now here's the thing. Most of graphing a linear inequality is the same as graphing the line. There are a few extra things you have to consider. Number one, you have to consider whether it's greater than or equal to, less than or equal to. If it's or equal to, we're going to draw a solid line. If it's not or equal to, if it's just greater than or less than, then it's a dashed line. Okay. Secondly, we have to consider the shading. Okay, so the last thing we do after we get a line in place is we'll decide which side of the line actually holds the solution set. Okay, so let's take this first example. Y is greater than 3 over 2x plus 1. That's in, again, slope-intercept form, except that's not an equal sign, so it's not an equation, it's an inequality. And we're going to graph then the y-intercept, which would be at 1. And then the slope of this is just 3 over 2, so that's rise over run, go up 3, right 2, up 3, right 2. Okay? And then, yes, when you consider whether you're going to graph this as a solid or a dashed line, it's about whether there's an or equal to bar here or not. Basically, the solid line is equivalent to the solid circle when you're doing these on a number line. And the dashed line is equivalent to the open circle when you're graphing things on a number line. Okay. Now, you can use a straight edge and just kind of dash, 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 dash. I do have a feature on here, so I'm going to try and use that. Hey, that didn't work. Oh, I got to pick it after. Yeah, try it now. So you're not going to get dashes that small, but just dash, every half inch or so would be fine. Maybe quarter inch is probably what I mean better. Okay. And do make sure you put arrows on there. Oh, now I got to get that back. Okay, so that's a dashed line with arrows. Now, think about this. With the inequality being the way that it is, what's true is that either all of these things over here are solutions to this inequality, or all of these things over here are solutions to the inequality. Okay. Now I have two things for you. Number one, you can always use a test point. You can always pick a point that's in one solution set or the other, one set or the other, and then just pick it and see if it works. If it works, like if I pick this number right here, this point right here, -3, 2, and I plug -3 in for x and 2 in for y, and the inequality is true, that means that everything over here, including that point, is part of the solution set, and we're going to shade this way. Okay? If it's false, that means that the other side, that means that all of these points don't work. It means the other side will work, and that's the way we're going to shade. Now, I say shade. What I actually do is I just draw a couple of arrows. If you're into coloring or whatever, you can shade it in if you want to. That's going to present a little bit of a slight more challenge when we're solving linear inequalities. When we're solving linear systems of inequalities. So I'll show you what I do, and it works pretty well. Okay. But first of all, we got to pick a test point. I like 0, 0. As long as the line itself doesn't pass through the origin, the easiest point to use is 0, 0. Plug 0 in for x and 0 in for y. This immediately becomes 0, and you're left with asking yourself, is 0 greater than 1? Now, again, you can only use the origin if the line itself doesn't pass through the origin. You need to pick something that's off the line, obviously. So is 0 greater than 1? No, it's not. That means that this point right here, 0, 0, is not part of the solution set. That means the other side is. Okay, and that's all I do right there. I just use 2 arrows. Again, if you want to get in here and color, that's fine. I got a tool for that too. And you can shade away, right, if you want to. But I kind of like the arrows, and it works really well with what's coming down the road here in another chapter or so. Okay, so that's one. Consider this example. Let me show you. We just did that example there. That's example 1. And there they have a dashed line, and they shaded on the one side of it, the upper side of it. Okay. Now, I got to give you a rule. I'm going to wait on that just for a second. Here's a situation. A restaurant has only 15 eggs until more are delivered. An order of scrambled eggs requires 2 eggs. An omelet requires 3 eggs. Write an inequality to model all possible combinations of orders of scrambled eggs and omelets the restaurant can fill till more eggs arrive. Graph the inequality. Now, I don't know if you recognize the urgency of this situation, but we are a breakfast restaurant, people, and we only have 15 eggs left. Okay, so I hope the guy that we sent out to the store doesn't get lost. I used to work in restaurants. This does become a crisis. I used to work at Pizza Hut, and we ran out of cheese, and they wouldn't let us close. That's a real story. All right, anyway. Sometimes when you read a problem like this, it becomes a little bit difficult for students to figure out just what the variables are. You got to read through and identify, what is it that we don't know. The variables are things that we don't know. So it's not the number of eggs, right? Because we know that 2 eggs goes into scrambled and 3 eggs goes into an omelet. What's actually unknown here is how many of those things we're going to sell. We don't know how many orders of scrambled eggs we're going to sell. That can vary. The number of omelets that we sell can vary. So let's let X be scrambled, and let's let Y be omelet, as in the number of them, orders of scrambles and orders of omelets, okay? And you should get inequality out of this situation. You see, 2 eggs goes to every order of scrambled, and 3 eggs goes to every omelet, and the number of eggs cannot exceed 15. This is our inequality. Now, just as I've taught you with standard form with lines, this is standard form, except that this isn't an equal sign. Just as I've taught you, though, what I would do is get intercepts is what I want to say. Plug a 0 in for X and see what Y is. Plug a 0 in for Y and see what X is. If you plug a 0 in for X, this is gone. You got just to divide both sides by 3, there's 5, okay? So if we sell, basically what that's saying is if we sell nothing but omelets, we can sell 5 before we're out of eggs. If I plug a 0 in for Y, you're going to get a 7.5 here, okay? So if we sell nothing but scrambled, we can basically do 7, and then we have 1 egg left over, okay? Now, what is that? Well, these are intercepts that we can actually graph, and I'll just show you their graph. So here's our 0, 5. Here's the 7.5 comma 0, although they did 15 over 2. That's 7.5, okay? And here's the thing. The shading on that, let me write it again. 2x plus 3y less than or equal to 15. If I plug in the origin, like we did on the first problem, plug a 0 in for X and a 0 in for Y, you're going to get 0 is less than or equal to 15. Now that's a true statement, meaning that we would shade back towards the origin. If I did arrows, I would point this way, but actually they're going to just shade it in. Oh, that's the next one. Okay, anyway, so they've shaded it in. And here's what you got to understand about this, that this is an inequality. The shaded region represents all of the different orders that we can accommodate, right? Can we sell, we have 15 eggs left. Can we sell 1 scrambled and 3 omelets? Yes, we can. 1 scrambled would be 2 eggs, 3 omelets would be 9 more eggs. That's a total of 11. We have 15 to choose from, so that works. And look, 1, 3 is in the solution set. Can we sell 3 scrambled and 3 omelets? 3 and 3, yes, because 3 for scrambled would be 6 eggs, 3 for omelets would be 9 more 6 plus 9 is 15. Now look at that, 3, 3, 15 is maxed out. That's our last egg. And notice that it's on the line. Not a coincidence. Could we sell 6 scrambled and 1 omelet? Yes, here it is. 6 scrambled and 1 omelet would be exactly 15 eggs. Could we sell 6 scrambled and 2 omelets? No, because 6 scrambled and 2 omelets would be more than 15 eggs, and notice that 6, 2 is outside here, right? So literally the shaded region represents, and really would be the points where the grids come together, and even at the zeros, everything that's where I'm putting dots, and I'm not going to do all of them, but these would be where we can sell that many of those combination of orders. Okay, that was a fun one. All right, that one's back here. Okay, so take what we now know about graphing absolute value equations and what we now know about graphing inequalities and put those two things together, and you're graphing absolute value inequalities. So here we go. By the way, this is not in vertex form. This 2 is inside the absolute value, so I'm not going to try to pick out a vertex here. I'm going to use a t-chart. And I'm going to pick 0. And 0 times 2 is 0. Absolute value is 0. Minus 3 would be negative 3. I'm going to pick 1. And that's going to give me 2 minus 3 is negative 1. And 2 is going to give me 1. And 3 is going to give me 3. And I'm going to go the other direction now. Negative 1 is negative 2. 2 minus 3 is negative 1. And this is my vertex, right? Okay. And then so you can expect negative 2 is going to produce positive 1. Negative 3 is going to produce positive 3. All right. Now, I'll plot those points, and then we need to think about, again, solid or dashed. If you said solid, you are correct because of the or equal to. Okay. So I'm going to draw those in. Solid line because of the or equal to again. And then the last thing we need to do is shade. And it's the same deal. Okay, now I told you I was going to tell you a rule before, and I'm going to go ahead and give it to you now. The rule is if it is in y by itself form. So the y is on the left, and then you have your inequality sign, and then you have everything else. Okay, and it must be that. If it's in standard form, this doesn't work. If it's in any other form than y by itself, this doesn't work. But since that's what we have here, you've got y, and then you got y by itself here, and then you've got inequality symbol and everything else. Here's the rule. Greater than is up, less than is down. The shading is going to be up from this graph. That would be this way, kind of the inside. Up from here is this way, so up, whereas this all here would be down. If this were a less than, instead of a greater than, we'd be shading down all of this stuff right here instead of up. Okay? That also works for lines. If it's y by itself, greater than is up and less than is down. Now, in this situation, you could always use a test point. So let me just prove it to you one more time. If I picked, well, let's just prove the negative. Let's pick this point right here. That's 4, negative 1. If I plug 4 in for x and negative 1 in for y, that's negative 1 is greater than or equal to the absolute value of essentially 8 minus 3. Okay, so that's 5. Is negative 1 greater than or equal to 5? No, it's not. And the reason that it's not is because I've already established that the solution set is in here. Any point that's outside of it is going to make the inequality not true. Let's use the good old origin again. Origin is in the solution set because it's right here, and is, I'll just put it right here, 0 greater than or equal to the absolute value of 0, 0 minus 3. Is 0 greater than negative 3? Yes, it is. Okay, and that would happen in an inequality sense. That would happen for any point that you picked in here, and it would be false for any point that you picked out here. Okay. Now, almost done. With that in mind, look back at our first example. Our first example was greater than, and this again is up. Now I know that sometimes they can feel more like left and right than up and down depending on how steep the line is, but it's not about left and right, it's up and down. And clearly this is up and this is down. And this should be up because that's greater than. If it were less than, it'd be the other way. All right, last one then. With that new rule in place now, we should be able to do this last problem where they give us the graph and we need to write the inequality. And it does say the boundary line is given, except I whited it out here, so it's not here anymore. Because we don't need it. We should be able to do this without it. Let's do the line first. Let's do B first, and then we'll come back to A. The line. Write something in slope-intercept form. Y, and then you're going to have an inequality symbol here. We'll come back to that in a minute. Notice that from one point to the next, we're going down 1, right 2. Down 1, right 2. Isn't that a slope of negative 1/2 times x? And then the y-intercept here is 3, plus 3. Okay, so we would have learned that in the last chapter, just writing something in slope-intercept form. And then we'll come back and do the inequality symbol. It's going to be or equal to because that's a solid line. And because the shading is down, it's going to be less than. Okay, so that's all the components of what we need there. Y is less than or equal to -1/2 x plus 3. Okay, let's do the same thing here and let's use vertex form. Remember from the previous lesson that vertex form is y equals a times the absolute value of x minus h plus k. Okay, well the a value is clearly 1 because it's just like a parent function in that way. Up one, right one, up one, right one, up one, right one. Here's up one, left one. So the a value is 1. It's positive 1 because it opens up. Okay, so y, now it's not equals because it's an inequality, but this is vertex form for an equation. So I'm just going to leave that out again like we did in the last one. The a value is 1. You can put a 1 there if you want to, or you could just totally leave it out. In fact, that looks weird to me, so I'm going to take it out. And then it's x, and then you just got to figure out what the vertex is. It's 2, -1. So this would be x minus 2. Remember, it's x minus h. So h value is 2. And then -1, so plus -1 or just -1. Okay? And then finally, I'll consider the inequality symbol. This is shading that's up, so it's greater than. And the line is dashed, so it's not or equal to. I'm not going to put anything here. This is it. Yep. All right, thanks for watching.